Okay, next let us see how we will represent the data. So we have collected our data. For each of those cases, n cases, we have got our Wi, which we know, which we have administered, and the Li's that we have measured. So we have got n pairs Wi, Li. Now we have to know how we represent the data inside the computer. So this is a crucial step, and I have seen some people who know linear model well, yet for a given problem they do not know how to express or how to store the data in the computer such that R or SPSS or SAS or any standard software can read them. Again, that box diagram will help. So this box diagram is of crucial importance. So I have the box diagram, and you can see that in the box diagram you have got this W, the input, and the L, that is output, and of course you have random error. Now the way you have to lay out the file is like this. There should be two columns. There should be as many columns as there are arrows in this box diagram other than for the random error. So in this case I have got W, one input arrow, one output arrow. So there should be two columns in the data file. There should be no column for the random error which is not observed. So the way you should write it is like this. I have one input W, one output L. So I have written W and L, my variables. So these are my variables. I have got W and I have got L. And I am writing down all the values of W that I have chosen. Suppose I hung 1 kg, then 1.5 kg, 2.0 kg. These are all uniformly spaced. They do not have to be uniformly spaced, but since they are under my control, the natural choice is making them uniformly spaced, and these are the measured quantities. Say these are measured in something like centimeters or something, whatever, all in some same common unit. So just observe how I have represented them. In this example it is pretty trivial, but for other examples it will be sometimes confusing. We will see such examples later. So understand how this layout is connected with this box diagram. Number of columns always equal to the number of arrows, including input and output, excluding the random error arrow. Number of rows always represents the total number of springs that you have taken. How many of such black boxes you have taken? It is always this. And you are writing for every trial of the experiment, the values are written as single row. One case, then another case, like that. Now when we want to represent this in a file, typically in a text file, I would suggest that you just store it directly, give the headings L and the two sets of values. And this is ready for ingestion in any standard software like R or SPSS or SAS, whatever. So this should be the format. Always you should be able to write down the black box first, and the black box should dictate how your data layout should be.